Alright guys, we're going to be going over page 109, problem 1. Emma and her friends hiked 1 1/3 miles on Saturday. The next day they hiked 2/3 of miles. How many miles did they hike in all? I need to do a number model and an answer. So in all, that kind of tells me we're going to add. What two things are we going to add? Well, we're going to add 1/3 mile and 2/3 miles. So 1/3 plus 2/3 equals m for mile. That would be the total distance they hiked. Well, let's go ahead, let's start with our denominators. They're the same, so we don't have to find any equivalent fractions. So I'm going to take 1/3 and 2/3 and add it together. 1 plus 2 is 3. The denominator remains the same. So I have 1 and 3/3. But I know that 3/3 is the same as a whole. So there's 1/3, 2/3, and 3/3. So instead of writing this as 1 and 3/3, I'm going to write this as 2. So they hiked 2 miles. Now we're going to go ahead and multiply. I have 375 multiplied by 3. If I think about making this easy to do in my head, I would take 400 multiplied by 3, and I get 1,200. So my answer, my product, needs to be close to that when I multiply. So now I'm going to go ahead and I'm going to multiply this. So 3 times 5 is 15. Regroup the 1. 3 times 7 is 21. Plus the 1 is 22. I always like to cross off my regrouped numbers as I go to make sure I use them. 3 times 3 is 9. Plus 2 is 11. So my answer here is 1,125, which is pretty close to my estimate of 1,200. Now let's go ahead, let's take a look at this number here. I have 375 multiplied by 9. Very similar to this last problem, except for this problem is 3 times bigger. So if I think about this product here, my answer could be around 3,300. Or if I think about numbers that are easy to do in my head, 400 is close to 375 multiplied by 9 would be about 4,600. Sorry, not 4,600, 3,600. Sorry, guys. So 9 times 5 is 45. So the 5 goes here, regroup the 4. 9 times 7 is 63, plus 4, 67. Cross off because I used it, regroup again. 9 times 3 is 27, plus 6 is 3,375. So pretty close to my estimate there. Alright, on these ones we're just going to use order of operations to help us solve. I need to remember that PEMDAS, so I do parentheses first. Right? Then I would do exponents. Then I would multiply and divide in from left to right, and then add and subtract from left to right in that order. So given PEMDAS, I'm going to do parentheses first, and I always like to rewrite. And here I have a little bit of space, but when I get to bigger problems, I'm going to want to use some scratch paper, line paper, graph paper. 28 divided by 7 is 4, and 4 times 3 is 12. Now here I'm just going to use some graph paper because I know this is going to be a lengthy problem. So here I want to do parentheses first. So I have some grouping symbols here. I'm going to go with 14 divided by 7. I know that's 2 because 7 times 2 is 14. I'm going to put my grouping symbols back to make sure I'm following the order. I'm going to go ahead and do this one here. 12 divided by 6 is also 2, and 6 times 2 is 12, just for the check. Now that's still in grouping symbols because I have these outside ones here that I needed to follow. They're right here in case we didn't see them. Now I'm just going to add these together because I'm doing what's inside first, my grouping symbols. 2 plus 2 is 4, and then rewrite times 5, and then 4 times 5 is 20. And I always like to rewrite so I don't lose my spot. Now here, I need to follow PEMDAS. So first is parentheses, and when we get to the parentheses, then we got to kind of follow the order here. Well, then the order would tell me exponents. So on this one, I'm going to do parentheses, then exponents. So 3 times 10 to the power of 2, which is 10 times 10, which is 100. And I'm going to rewrite so I don't lose track. I'm going to go ahead and do what's inside this parentheses. 5 times 2, which is 10. And then 3 times 100, 300 plus 10 would be 310. Alright, our final one on this problem. Here, another long one, so I want to make sure I rewrite as I go. So this 32 plus is going to go towards the end because it's not in parentheses. Now I have very outside grouping symbols, so I need to pay attention to how I do this. First, we're going to go with the innermost one, which would be 8 times 2, which is 16. Then I'm going to divide, and then 2 plus 2 is 4. So make sure we follow all the way around. So I'm going to rewrite 32. Now what's 16 divided by 4? Well, 4 times what is 16? 4. Okay, now I'm done with those parentheses, grouping symbols. Now I'm just going to have 36. Use the fractions listed in the blanks to make the statements true. So I have to think about what's going to get me something less than half. So I know 1/3 is less than half and 1/6 is less than half. So that should work. I know 2/7 is less than half. I'm going to stick with what I know for sure will work. That will be the 1/3 and the 1/8. Now here I need to have a fraction bigger than 1.5 when I subtract. So I have 1 2/3. I still need to make it bigger than 1.5. Well, 1/6. Huh. Well, 2/3 is how many 6? Let's see. 3 times what? 3 times 2. What I do to the denominator, I do to the numerator. So 4/6 minus 1/6 is 3/6, which is the same as half. So I'm going to want to go with something smaller. So I'm going to change out this 1/8 here. And I know 1/8 is smaller than 1/6, so that will give me something smaller. And I can always check with the back of the book as well. Now I have 2.5 plus, or sorry, I need to get something bigger than 2.5. Well, 2 3/4 plus anything is going to be bigger than 2.5. So I'm going to go with 2/7 here. Now if I come back to this problem here, let's see if I can get a number bigger than or less than half. If I put 1/6 here, well 1/6 is the same as, is 1/6, but 1/3 is the same as 2/3, so that's not going to work here. And if I have 2/7, I'm going to go ahead and have to think about really which ones would work here. I'm going to go with 1/8 again. I'm going to stick with that because I just reread the problem and it doesn't say I can't use the same fraction twice. Now write a number story that could be modeled by the number sentence in 3A. So you have 10 to the power of 2. So what could you have that's 100? And then you would multiply it by 3, so you would get 3 times the amount, and then you would add 10 more. So you really got to think about how you can word this one, and I don't want to give it away completely.